Good morning, everyone. This is Sarah Kirby from NC State University. I'm actually not at NC State University right now. I'm actually working from home, as I'm sure many of you are, given the new world that we're living in. I do want to welcome you to this webinar on how to evaluate your radon mitigation system. We're excited to be able to offer two new webinars in partnership with the NC Radon program. We'll be doing one this week and I believe one next week. But we are pleased to be able to be sort of your technical platform host. I do want to let you know that we will be recording this. I will be monitoring the chat box. So as Bruce presents, when it's over, I'll make sure that all of your questions are read to him and answered as best he can do. Hopefully this will go smoothly. It's a little bit different when you're at home, so you're not quite sure. But I do want to turn this over to Philip Gibson, who is the radon specialist with the NC Radon program. And as I've said, I think on every one of these, he's the brains behind these. And I think they've been great for those of us that have been able to participate. So Philip, I will turn it over to you and let you do your introductions. Thank you.
Hello, everyone. Thank you for joining us today. Before I introduce our speaker today, I want to thank you again, Dr. Kirby and NC State University Cooperative Extension Service for continuing to support and serve as our partner in our effort to educate North Carolinians on radon testing, mitigation, and the health impacts of radon exposure. Our webinar today is titled Inspecting Radon Mitigation Systems. So the reason for that is this, reason for this event. The installation of radon mitigation systems in North Carolina buildings began in the early 1990s. And it is recommended that existing radon mitigation systems be evaluated and maintained so as to ensure that the system that was installed is performing in the manner intended and that is continue to be protected. So this is a guidance, if you will, a brief guidance. There's a lot more details as Bruce will get into, but this is the reason for this particular presentation. Our presenter today is Bruce Sneed. I'm extremely honored that Bruce has agreed to present today. He is a national leader and an advocate for the science and standards for radon testing and mitigation. Bruce is the Director of Engineering Extension at Kansas State University. Bruce has been a state extension specialist in residential energy, radon, and indoor air quality at Kansas State since 1982. Bruce spearheaded Kansas State's role in the Kansas Radon program for 21 years plus, and is currently leading the National Radon Program Services and projects for the U.S. Environmental Protection Agency, which that program is of service to all of you all, which provides technical assistance to the public through a toll-free phone line and web-based services. I recommend visiting their website at sosradon.org. So with that, please join me in welcoming Bruce Sneed.
Okay, well, good morning, and let me, let's see here. Can you see my PowerPoint presentation?
Not yet.
Not yet.
Not yet, okay. Let me, somehow I've lost the, here we go, share, there we go, okay. How about now?
Perfect.
Okay, excellent. Very good. Well, thank you, Philip. Thank you, Sarah, for organizing this and requesting my presentation. As I indicated in the chat room, I've got lots to present today, so I'm going to move quickly. I'm happy to provide a PDF of the PowerPoint presentation to participants afterwards. So, radon mitigation. Radon mitigation commonly reduces radon by reversing the air pressure relationship between the house or the indoors and the soil beneath the foundation. Why do houses have radon problems? It's because there are negative pressure sources, air pressure differentials created by a variety of driving forces that pull radon from the soil into the through the foundation into the air in the home. And mitigation strategies reverse that relationship by putting a vacuum or suction on the soil to draw the radon from beneath the home and vent it into the air above the home. This can help dilute the concentration in the soil, and other strategies can also be used to reduce radon by ventilation, but it's called active soil depressurization, and it's been shown to be the most successful way to reduce radon concentrations in home by preventing it from entering. You can see here that we achieve reductions regardless of the radon concentration, whether it's barely above 4 or 40 or 400, these systems work and can get the radon down below 2 picocuries per liter. We want them to be safe systems, to be durable, long-lasting. We need to have system monitoring so that occupants can determine whether or not the system is operational. We obviously want them to be economical to install and operate and energy efficient, and that's a key issue in radon mitigation. And ideally, they are quiet and unobtrusive in terms of the home. Here are the 2 most common configurations of active soil depressurization systems. It is primarily the location of the fan, which can either be in an attic or above an occupied area in a non-occupied space, or outdoors. So these are common outdoor locations and configurations you see in the cross-sectional drawings in the middle of the slide. Either approach can work. Both of them comply with the mitigation standards or can be installed according to mitigation standards. And you see in the bottom of the slide a U-tube manometer, which is simply a pressure indicator showing that the fan is creating a continuously operating suction to draw the radon from beneath the home and vent it into the air above the home. In a radon mitigation system, an active soil depressurization system, there is pipe that is under negative pressure, that's below the fan, and pipe that's under positive pressure, and that's above the fan. So air can be drawn into the pipe from below and can exhaust from the pipe above. And we need to understand this because it's one of the reasons why the fans are located either outside or above living area, so that if there are leaks on the positive side, we don't have the potential for re-entering of radon into the home. ASD has been applied to all manner of foundation systems: basements, crawl space, slab on grade, drain tile, and these series of slides just simply show the different kinds of configurations that and foundation types and how ASD is applied. Sump systems, membranes in crawl space, block walls, much rarer application of active soil depressurization is 2 block walls. And then of course, because crawl spaces can be non-habitable and even non-accessible, depressurization of the crawl space is another option as well with ASD. These next 2 slides are simply detailed drawings of the significant components and features of an ASD system. This is a 2 suction point system. Whether it's 1 or 2 suction points can be determined through diagnostics in terms of the foundation and analysis. But this gives you a kind of a full cross-sectional view of the significant components and some of the key concerns that we'll be touching on as we talk about inspections. Here's one for a crawl space showing the pipe going through a membrane laid on the floor of the crawl space, and some of the key features associated with sealing of the crawl space membrane and pipe configuration, penetrations of the membrane, and so on. So these are resources that are available to help you understand the significant components of ASD systems. The good news is ASD systems 99+% of the time can achieve radon reductions down to below the EPA guideline of 4, and I would say at least 70% of the time or more down below 2. Here's a graph showing the pre-mitigation radon fluctuations with an average of 7.9 before mitigation, and then the post-mitigation results from a CRM in green showing an average of 0.9. Anything down below 1 is excellent performance for a ASD mitigation system. So how do we evaluate and inspect radon mitigation systems? What references do we use? And there are three U.S. radon mitigation standards that I want to touch on briefly. The first and most recent and current is the soil gas mitigation standard produced by the ANSI-ARST Consortium. The website where it is available for free viewing or for purchase is there in the slide. And it's always important to check your state radon program or your local jurisdiction or the National Proficiency Program for what standard is going to be in use. And mitigators should be designating the standard they are using for compliance in terms of system evaluation for systems they are installing. In addition to this most recent and current standard, we also have the EPA Radon Mitigation Standard put forth in '93 and the ASTM E2121, which is discontinued. The reason I list these is because some states have licensing requirements and have recognized in legislation or regulation the EPA Mitigation Standard or ASTM. And so the national proficiency programs, NRPP and NRSP, have to recognize them because the individuals have to comply with state requirements. And so it's important for the national standard, national proficiency organizations to recognize that. So when we talk about standards, we need to understand which one is in play, which one is either the jurisdiction you're in, state, city, or county, recognizing or using. And if you are not in a certifying or licensure state or jurisdiction, what one are you using as a mitigator in terms of the installation and what you're trying to comply with? So these are some of the ways standards are adopted, and here's the stated purpose and intent of the standards. EPA has looked, again, done in 1993, addressed many things that are somewhat extraneous now in terms of the standards. And ASTM 21 was similar to EPA radon mitigation standards, but they were intended, again, for a set of regulations that states could adopt. The soil gas mitigation standard specifies minimum requirements for reducing soil gas entry into homes, and it's applicable to residential structures not more than 3 stories above grade in height, single-family structures, and ones that don't contain more than 4 attached dwelling units on a continuous foundation. In addition, instead of saying radon gas mitigation standards, it says soil gas, and that's because this standard also addresses vapor intrusion and other soil gas mitigation for installing systems from chemical vapor intrusion. So, who's doing the inspection? That's a key question. Who is responsible? What is their role in terms of inspecting the mitigation system? Of course, many home inspectors doing radon measurements in existing homes would be candidates for using checklists and other tools to inspect the system. If there is a regulation or licensure in the state radon program person might be inspecting the system. Radon mitigators might be inspecting pre-existing systems or systems installed previously or systems installed by other contractors. Certainly building code officials in jurisdictions that have adopted radon-resistant new construction requirements might be doing inspections, and the homeowner is another candidate, and perhaps there are others as well. So what's the focus for each of these individuals or groups? Well, for the home inspector, they're concerned with compliance with standards, with health, certainly primarily, and with safety, health and safety. And what is the status of the system and performance of the system that they are inspecting. State radon inspectors would look for compliance with standards. Is the discharge properly located? Does the pipe slope to allow condensation to drain? Is there a U-tube manometer or performance indicator? And other issues. The radon mitigator is going to look for compliance with their own quality assurance plan, and radon mitigators should have their mitigation quality assurance plan that describes what they do, what standard they are installing to, and how they verify and assess that. Building code officials are going to look for compliance with codes. Does it meet the code standard that they've adopted or the building code version that they are using? And for the homeowner, there's a webinar coming up a week from today. Brian Hansen will be talking about inspections by homeowners, and that's something I would refer you to. So the good news is there are many checklists available that we can tap into and use depending on our purposes. What I'm going to talk today about is primarily the Measurement in Homes Companion Standard and the ASHI standard, in the American Society of Home Inspectors standard and inspection checklist. There are other state-specific checklists, as you can see here, and other agencies or organizations or associations that may have checklists. The one that you see displayed here is actually the one designed by the Pennsylvania Radon Program for its for homeowners that have radon mitigation systems, and Brian may be referring to that next week. So let's look first to the MAH companion guidance, and you can see the protocol for conducting measurements of radon and decay products in homes there on the right. The checklist is provided for evaluating health and safety and the functional integrity of system components. They're not necessary for compliance with any standard or regulation, and again, it's designed for homeowners and inspection personnel. So these next series of slides go through this inspection checklist that is part of the ANSI ARST home measurement standard. And so on the left-hand side of each slide, you'll see the kind of focus or content area and the questions associated for the inspector. On the right-hand side, you'll see what is the recommended action if there is no as the answer to the questions posed on the left-hand side. So we're going to go through this checklist, which obviously is not quite in this format, but for presentation today, this is how I've arranged it. So a key question, of course, is, was there a radon test and what are the results and is it available? And if there's not, the recommendation would be to test for radon. Is there a FIS radon mitigation system and fan? If so, tests should be conducted to verify. And of course, we recommend, and the EPA recommends, retesting, as do the standards, at least once every 2 years for homes with mitigation systems. Where is the fan and where is the exhaust location? A key issue in radon mitigation system installation, sometimes a point of dispute, is the fan outside occupiable space, not beneath an occupiable space? And does it have proper fan wiring? If it's not properly located, the recommendation would be to relocate it to comply with current standards. And if the wiring is unsafe, then correct that. Does the system exhaust at least 10 feet above grade? Is it at least 2 feet above or 10 feet to the side of any operable opening to the interior of the home? And that would allow ventilation. And this is a common concern. If not properly located, the action or recommendation would be to bring the exhaust into compliance with the standard. Are there building exits for fire and safety that are clear of obstructions in terms of the radon pipe routing? Is the pipe configured properly so that the fire protection of walls or construction membranes are penetrated is protected, and they far enough away from electrical panels or other gas meters or other code driven requirements? Is there a viewable radon fan monitor? And does the radon fan appear to be running? The monitor or system indicator should be available for the homeowner or occupant to view on a regular basis, certainly at least weekly or more often. And is the fan running? The monitor would give you that indication. If it's not, then the recommendation would be to activate or replace the fan. Openings to the soil that allow radon to enter. Are all sump pump lids have rigid sealed lids? Are they well sealed? Are accessible openings to the soil closed and sealed except for those that might compromise water drainage? And if the lid is not properly sealed, it should be repaired or replaced. And certainly any accessible openings to the soil should be sealed as part of the standards. For non-habitable air spaces, common systems that draw air from behind a wall, from under a floor, from a crawl space, are openings to those spaces or zones closed or sealed to minimize the draw of air from indoor air or habitable spaces. And so this is important because there can be energy penalties when air is drawn out of the house versus radon being drawn from out of the soil, or we can potentially affect the performance of atmospherically vented combustion appliances. And what's the status of the foundation or crawl space vents? And are they permanently open and vents are installed? So what's the status there and what action might need to be taken if they're not properly installed? Then we move into the functional integrity of components. And you can see different versions of mitigation there on the left-hand side. and what type of system is installed. This is simply a list to check, say, what is the kind of system? Is it subslab, block wall, or some other method involved? It identifies what system is there. Then we look at the piping. Is the piping watertight and free of visible water leaks? Is it sloped to drain to allow condensation that will occur inside the piping system to drain back to the soil or otherwise be vented? Is the piping secured properly? Does the exhaust discharge without obstruction, without improper configuration? Are building materials safe from exhaust vapor damage? We don't want to have condensation on building materials. Is the piping durable and good repair? Fans. Is there a switch, plug, or breaker to turn off the fan within visible area of the fan? And are there flexible couplings connecting the fan to the pipe? And is the fan properly rated for radon system use and capable of processing water? Sump lids, are they fastened and sealed in a manner that allows removal for service? Are there flexible couplings that allow access for service? For submembranes and crawl spaces, are air intakes under the membrane free of obstruction so air can be drawn? Is the top of the membrane free from standing water? And are there sizable membrane openings to the soil that are closed? We want a well-sealed membrane as much as is possible when the crawl space is accessible. Are the edges of the membrane well sealed? And is it of durable material that will withstand movement, activity, surface activity, storage, etc.? And is it secured properly to the surrounding perimeter wall? There are other less common radon methods, and the checklist simply says, does it consist of piping, radon fans, and closure? And you may need help from a professional in evaluating these. So that's a very quick review of the checklist from the HOMS standard, Measurement and Home Standard. I wanted to cycle through a series of slides about exhaust and configuration of exhaust from the standard. This shows the trajectory of the exhaust, which should be vertical or within 45 degrees off of vertical axis, ideally. It should be 10 feet above grade. Should be at least 4 feet above any operable portion of the window and 10 feet from any opening back into the building, horizontal distance away. Should be at least 10 feet from areas where people can occupy or be, such as a balcony or patio. And the trajectory is vertical, preferred, or at a 45-degree angle, but it is not allowed to do a umbrella handle and turn the trajectory back down. The roof should be at least 6 inches above the roof if it's not through the roof, and if it penetrates the roof, it should be at least 1 foot above the roof. Now, obviously, different climate zones and snow loads might lead to different code requirements in your jurisdiction for a greater height of the pipe above the roof surface. If you have a configuration of the system where the discharge cannot get above the roof for safety purposes, for example, and here's an example where the discharge is at least 20 feet off the ground, and if you cannot go above the roof, then you need to provide testing inside an occupied space adjacent to where the discharge is. This is, again, part of the standards. If you configure the discharge with a horizontal projection, a 90-degree as you see here, then the distances increase appropriately to a 20-foot height if there is a discharge like you see configured here above grade. And if you use a diffuser on top, a rain cap or something that projects the discharge horizontally, the distances increase 4 feet above operable openings and 15 feet from operable openings or 4 feet above, either one. I know I'm moving quickly. I want to get to the ASHI, American Society of Home Inspectors, standard for home inspections. And this is a voluntary standard that ASHI has produced through their process. And it talks about what it observes. Again, it talks about asking for radon measurements and documentation and what they want to inspect, many of the items that we've already talked about. Fans, location, electrical connections, exhaust, et cetera, et cetera. And I'm going to go through a number of pictures. That's why I'm moving so quickly. So this is a picture of a graphic from the ASHI checklist. The ASHI checklist actually has 68 items. I'm not going to go through all of them, but I am going to go through a significant number because it provides pictures of many of the things I've just talked about with the MAH companion checklist. It's a general checklist. It doesn't replace a radon test to determine the radon level. And of course, consumers are always urged to have a radon test performed and use appropriate kits or appropriately licensed people to get those tests done. So here we go. You'll see that up the left-hand side is the title of the item being inspected. And on the right-hand side are some pictures of what may be either features or good examples or bad examples of what we're talking about on each slide. And on the left-hand side is what is the question posed by the inspection checklist. The first one is there a radon test available within the previous 2 years? And you'll just see some pictures of test kits there, as well as a door hanger for a home that's under a radon test in progress. Number 2 is identifying what's the type of mitigation system installed. Is it an active system which has a fan creating a negative pressure pulling radon from beneath, or is it a passive system, radon resistant new construction, which, as you see configured here, is a straight pipe running from the subslab zone up and through the house and venting through the roof to provide a passive vent for the radon in a newly constructed home. What is the foundation type? Basement, crawl space, slab on grade. What are the foundation materials? Is it rubble, brick, concrete, poured concrete, concrete block, all-weather wood foundation? Again, it just identifies. And so the checklist goes through the kind of the entry-level components of the system. What does the basement or crawl space floor consist of? Is it a slab? Is it open soil? Is it gravel? What kind of floor materials or foundation material do we have on the ground? Are there openings in the foundation and the condition of the foundation? And you're looking at some access to crawl space here, either graphics or doors that show openings between the basement and the crawl space that one is wide open. You can see the radon vent pipe there in the center. And the bottom 2 show weather strip doors that provide airtight gaskets and separation from the crawl space to the adjacent basement area. And it's important that these doors, if they are part of a radon mitigation system, be labeled as such. And you'll see that requirement come up again. Are openings and penetrations sealed between the foundation or through the foundation from the basement to the soil below? You see 3 slides here, one showing the top one, a tub blockout where the drain piping for the tub is, and that's open soil directly that can allow radon in through the foundation. You see someone injecting foam underneath a furnace pad in the middle slide, and then someone caulking a sealer around a slab penetration, a slab piping penetration in the slab in a basement. So what is the condition of these openings? Is there visible evidence of backdrafting or other combustion or vent system defects? And the slides here show someone using smoke or their hands to sense the draft coming off a water heater. In the top slide, you can see all kinds of deterioration associated with what may be improper venting, as well as on the front of the furnace, some furnace rollout down here in the center portion. So again, we're looking for evidence that combustion appliances may not be venting properly, so that if they're not, we don't want to install a radon mitigation system that might aggravate or make the conditions even worse for a poorly venting appliance. Sumps. And again, you can see the number associated with the ASHI inspection item here. The cover includes a physical accessible port to test the operation of the pump, a disconnect with flexible connectors like you see in the bottom slide and over here on the right-hand slide. And is there a way, to remove the cover without causing damage? You can see labels on the upper portion here, the radon vent pipe coming out here in the bottom center, and a view port. So again, the sumps and their covers have several requirements that we need to inspect. Are the penetrations through the sump lid well sealed so that gas cannot escape from beneath the lid into the space? And you can see in the slide here, we have labels on the sump lid. One is a clear plexiglass lid up in the right-hand corner. The other one is a solid one, but it is well labeled, as well as the pipe is labeled, so that folks identify and know what the pump systems are. Is there a label stating radon reduction system and component of radon reduction system? Do not tamper or disconnect. This is important that we identify every component of an ASD system as much as possible, so future homeowners and current homeowners can know the importance of this, as well as other contractors that encounter the systems and may modify the systems and hopefully do so knowingly without impairing the performance of the system. We moved now to vapor retarders in crawl spaces. And is there a vapor retarder present? Yes or no? And is action needed? So you see two pictures here of vapor retarders being laid in either new construction or an existing crawl space here. You can see the membrane with perforated pipe running down through the center of the membrane to provide pressure field extension for the fan's vacuum effects. Are the seams of the vapor retarder lapped at least 12 inches and ideally sealed? If they need to be lapped, you can see indications of sealing here with caulking material and with taping material here in the bottom photo. Is the vapor retarder sealed to the perimeter walls of the crawl space? And when we have a depressurization system, you can see in the upper slide the radon piping penetration over here in the corner of the crawl space, that the membrane's been lapped up the side walls and then actually probably bonded with caulking behind it, and then stripping is shot to the walls or adhered to the walls to provide a mechanical connection as well. And you can see that down below in the lower slide. Obviously, the lower slide leaves this portion in the corner of the crawl space soil uncovered, and that's not a thorough job. Another issue that can present itself in crawl spaces is whether or not water and collection of water from a variety of sources can gather on the surface of the membrane. And do you need to have provision to deal with that? So you see photos above and below here of water collecting in the crawl space on top of a membrane. And so it may be necessary to add a sump or some other means of drainage or water control in a crawl space membrane system. And that's if there's evidence of water problems prior to installation, hopefully this is addressed when the membrane is installed with a proper sump or other means of drainage. Mitigation fans. Is the fan labeled radon reduction system? You can see examples of fans here. One is in the center, properly installed, just an independent non-connected fan, and then upper right-hand corner shows a fan with improper installation because it's horizontally mounted, and that's contrary to all of the centrifugal inline fans that are used and available from manufacturers for radon mitigation. Is there a manometer or monitor accessible and functioning to show adequate pressure or some differential pressure on the information label? So you see two slides here. One is of a U-tube manometer mounted on a wall, connected probably through this little plastic tubing into a interior radon mitigation vent pipe. Labeling is there with information and explanation of the U-tube manometer function. And the upper one shows documentation hung on the wall, as well as the U-tube manometer with little arrows indicating where the pressure readings should be for this particular system. Here's the fan. Is the fan installed either in an attic on the exterior of the building or a garage where there's no conditioned space above? Yes or no, and what action is needed? So you can see an exterior mount fan here. You can see an improperly discharged and configured fan with no venting through the roof in the upper portion. Here's a fan that's upside down, and here's one that's being installed in an attic. Where is the fan is a key issue. Is it installed to prevent condensation and buildup? You see a proper installation in the center photo. You see two fans that are horizontally mounted and improperly installed in the upper and lower photographs here. This is contrary to all the recommendations, and this will allow any condensation to gather in the fan when it is mounted horizontally like this. Are the penetrations around the membrane well sealed? And you can see one in the upper slide with a sandwich of roof flashing, one above and one below, providing the airtight penetration in the membrane, and a poorer one done here where duct tape is supposed to somehow be a permanent seal. And I love duct tape, but it's not going to work as a permanent seal. Is the piping properly installed to minimize condensation and gurgling? These two photos show places where water and condensate can gather, creating a trap that can cause gurgling noises and either or complete blockage of airflow, reducing or eliminating the performance of the mitigation system. So pipe has to slope back towards the suction point or suction pit to prevent, or water drainage has to be configured. We move now to electrical installations. The fan should be properly wired. You see a fan here with, in the bottom right, improper wiring in terms of the penetration of the wiring box. You see a fan here that's wired through an extension cord, improperly mounted horizontally and plugged into a timer. And here's one where the fan is plugged in by an extension cord. These don't comply with current electrical standards or codes. Is an exterior fan hardwired to a weather-tight switch? The bottom slide shows a proper configuration of this. In addition to the condensation drainage line you see here, it's just a black tubing, and one that's improperly wired and improperly discharged in the upper right photograph. Is the breaker the circuit breaker in the electrical panel identified as the radon fan circuit? This is important because if the circuit is off and the fan stops, radon levels can return to previous pre-mitigation levels within 12 to 24 hours after the system stops operating. So this is another standard that the labeling addresses on the electrical panel. What kind of piping are we using? Is it 2-inch, 3-inch, or 4-inch? 3-inch or 4-inch is preferred. 2-inch can be used where there is very low airflows, like less than 40 cubic feet per minute. And so you just see a piping system here that has a subslab suction penetration on the left and then a membrane penetration here on the right. And you can see the pipe size has been varied according to the necessary airflow and vacuum. If you have multiple suction points joined together, you need to have a minimum 3-inch diameter pipe. And that's what's shown here in the upper slide, where there's a 3-inch vent to the basement suction point and a 2-inch vent going to a well-sealed crawl space. The pipe needs to slope to drain to allow condensate to drain out of the system. And you can see different configurations here. The bottom ones will not allow that condensate to drain. And so this is improper installation of the radon vent pipe. We want to make sure that our installations don't violate structural or fire integrity of building components and building systems. So you see the mitigator installing a fire collar around a radon vent pipe penetration from a garage into a basement space, or from a garage through into a ceiling above on the right-hand slide. These fire collars and other mechanisms can be installed around the pipe to seal a pipe in the event of a fire through the effect of the fire collar at compressing the pipe when it's fire occurs. Labeling. Vent pipe should be labeled as radon reduction system on each level where the pipe is visible. And you can see a label up close here in the upper right slide, and labels on the around the U2 manometer as well. Downspout material. Downspout material can be used as long as it's equivalent in terms of size to the 3 and 4 inch diameter PVC type pipe that is commonly used. One of the key challenges with downspout, which is frequently done for aesthetic purposes, is proper sealing. And that's why these slides show caulking and sealing, and some of the poorer installations in the upper right portion of the slide as well. But sealing downspout material, which tends to condense much more, is very, very important, not only for airflow, but for condensate drainage. Is the pipe configured and installed properly so it's airtight, as sealed, and has no visible openings or breaks? And you can see examples here of pipe that was not sealed, not glued, that were identified in inspections. And one where water leakage obviously occurs in a cold climate, creating these icicles and ice formations around the fan in the lower photo. Is the pipe properly supported with hangers for vertical piping every 10 feet, right? And here's an example in the center, properly installed, and a close-up of a pipe clamp, and a very unique use of duct tape to suspend the pipe improperly in the bottom photo. Are there hangers at least every 6 feet horizontally for horizontal pipe configurations? And you can see proper installation here with wiring, with joist, and then improper ones where a joist hanger or J-hook is used horizontally, and that's not going to provide proper support. So are we properly supporting the pipe so it doesn't sag? Here's pictures of an improperly installed mitigation system in front of an electrical panel, too close to a gas meter in the middle photo, and too close to an electrical panel in the bottom slide. So we want the piping to be properly distanced from these other building components due to code requirements. Is the pipe insulated where necessary? If it runs through an attic, either in a hot climate or a cold climate, it may be necessary or appropriate to have installation to prevent condensation either on the exterior or the interior. And that's a climate-driven issue. But you can see from these photographs that condensation and mold can occur on these radon piping systems because of the temperature of the air they're moving inside and the temperature of and conditions of the space through which the pipe is configured. Where does the vent pipe terminate? What is the discharge? And I've talked about this already. I'll just focus on a couple of photos in these slides. You can see on the bottom left what the initial configuration was for the radon vent pipe coming out of this little square dryer vent, melting the snow on the soil where the air was discharged. And then after the system was inspected and this defect identified, the new radon vent pipe, which runs up the outside wall and vents above the roof. And improper locations up in the upper portion here, too close to occupiable spaces outdoors. Again, further distance requirements for location of the vent pipe. And I'll focus on the bottom one. Obviously, this is not 2 feet or 4 feet above any operable opening within 10 feet. And so this is an improper termination. Rain caps. If you're going to put a cap on the radon discharge point because of acorns, walnuts, critters that you're concerned about getting in, and you put a cap like the upper right one on, it's going to lead to a recommendation to configure the discharge accordingly. Is there a cap? If so, why? Is it necessary? If so, make sure that it's properly installed. And the discharge, does it look like this on the upper right versus these poor configurations here in the photos you see on this slide? Okay, rapid fire, I know, but that brings us through the ASHI inspection checklist. And now I wanted to turn briefly to a checklist that is focused on radon-resistant new construction. And the one that I'm familiar with that I've seen comes from Gwinnett County, Georgia, Department of Planning and Development. I did a search earlier and this morning to find the website link where this checklist is located, but I couldn't find it on the Gwinnett County site. So I'll keep searching. I do have the checklist and be glad to share it with any of our participants. It lays out its inspection guidelines for RRNC in 3 versions: for a slab on grade with no interior footings, slab on grade with interior footings, and for crawl space. And I know you can't read. This is a picture of the inspection sheet itself for slab on grade construction, and the headings across the top address code and inspection items, like what is the item, such as aggregate size and thickness, then the code section that that item is identified in, and what the code requirement is in the yellow portion. In other words, what do we have to have for aggregate? A minimum 4-inch thick layer of clean aggregate. For the inspection section, it is when is that inspected? What is it? And then who's responsible? Is it a third party or the county building inspector? So that's what's going across the top of this checklist. And down the left-hand side are the construction elements, which begin with underslab aggregate, then the vent pipe, then the vapor retarder, then sealing of joints, penetrations and openings, and finally the power source. So this, for the, again, slab on grade construction version, lays out the items that are inspected, what code section is relevant, and what is the a summary of the code requirement that that item is intended to conform to or be compliant with. And so there are ones for the 3 foundation options that I described. Here we are. I'd be remiss if I didn't share with you from the history of inspections and feedback and resources that have been shared with me over the years, the Hall of Shame inspection winner. When this was inspected, the inspector found by moving the pipe that there was no penetration of the slab. The pipe was simply caulked to the floor. So it's really difficult for radon to be vented through 4 inches of concrete by a pipe. Then as he went up, followed the piping system through and went into the attic where the pipe came out and was to go through the roof, he found a roof flashing on the underside of the roof, which, okay, that might be appropriate to hold it in place. But when he pulled it back, he found that the pipe didn't even penetrate the roof. So this is our worst case radon inspection results, where there's a mitigation system that's simply false and does nothing. I know you won't encounter this, and all the folks that are probably on this call may have seen this, or hopefully not anything worse. And I hope that the content I've covered today has been helpful in reviewing the issues and items that we want to address. So that brings me to the end of my presentation. I know it's been fast. I'm happy to open it up now for questions and feedback, and would ask Sarah to help me with any chat items that have come forward, and turn to feedback and interaction on questions. And my contact information is there on the slide.
Bruce, thank you so much. This has been wonderful. And I just am amazed at the kinds of things people do, thinking either 1, they're doing the right thing, or 2, to get away from doing the right thing, especially your Hall of Shame winner. That was quite a sight to see. I do have a couple of things. Number 1, Philip was wondering if you would talk about the class that you may be offering in South Carolina in the near future. Could you address that first?
Sure. I'm working with Leslie in the South Carolina Radon program to try and conduct a radon resistant new construction training in the latter part of June in association with the Region 4 stakeholder meeting. And so we're working to try and make that happen. It would be a 4-hour classroom type. We're hopeful, and we'll all be able to get back together by then, face-to-face, classroom type CE course with NRPP approval. And this would focus in on radon-resistant new construction. What are the components and guidelines and standards that guide us in installing radon-resistant new construction in single-family and duplex type construction. So that's what we're hoping to put together again for the last week of June, probably on Tuesday of that last week of June. And again, we're working on that. We kind of are in the planning stages, but that's our goal, to have that, to conduct that.
Wonderful. Wonderful. We did have an individual ask about North Carolina specific laws, but North Carolina does not have any specific laws related to radon mitigation techs and companies. However, the NC Radon program does have a link to the National Radon Proficiency Program and the National Radon Safety Board so that folks can find certified radon professionals, because that's what we would encourage people to do, especially to avoid what we saw in that last Hall of Shame that we saw. If anybody else has questions, they can type them into the chat box for Bruce.
And I'm happy to go back and to any particular slide if someone has identified something that I missed or they want to get more information about too. Okay. I see Phil would like to know about my availability for technical trainings. Yes, we are a regional radon training center at Kansas State University. We can serve 33 states. We're happy to work with any state radon program to provide technical training. We've worked with Tennessee, Nebraska, Missouri, Kansas, Wisconsin, and other states to provide technical training focused on specific audiences and their needs, real estate, home inspectors, building officials, contractors, and of course, radon measurement and mitigation services and service providers as well. So we have a large number of both classroom and online webinar and correspondence course offerings, entry-level measurement mitigation, as well as schools multifamily measurement mitigation, multifamily and various CE courses at radoncourses.com. And I'm happy to work with states and other groups and associations to try and meet their technical training needs. There is also the Regional Radon Training Center at Rutgers University, Eastern Regional Radon Training Center, and they can provide technical training and assistance too to many of the states in the eastern portion of the country.
Great. Thank you for sharing that. Any other questions or any other thoughts before we finish?
Bruce, I want to take a moment again to thank you so very much for this presentation. I learn something every time I hear a presentation from you, so thank you.
Well, my pleasure. Again, I know it was a lot, but as I said, happy to share the PDF so folks can further review it and see in more detail some of the things that were on the slides.
Certainly, and if you want to email that to me, I can email it out to everyone.
Happy to.
Thank you.
Well, it looks like we don't have any more questions. I do want to thank Bruce as well and thank all of you all for joining us. And hopefully you will join us again next Thursday at 11 o'clock, where we'll talk some more radon and look forward to having you.
Great. Thanks so much, folks.
Thanks, Bruce.